Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Catchpoint. My name is Cody, and welcome back to Tech Strong Learning. Before we dive into things, I have just a couple of notes to review with everyone. First of all, we are recording our session today. So if you happen to miss any of our conversation, if you'd like to watch again later, or if you'd like to share this with the rest of your team, we will be sure to send you a copy of the recording via email shortly after we conclude this session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you have specific questions, we do want you to send those questions into the Q&A tab on the right side of that chat section. Sending your questions to the Q&A helps us keep track, and we have time set aside at the end of our program today to address as many of your questions as we can fit in our time. So please do send those questions into that Q&A section. Finally, we do have two $50 Amazon gift cards that we will be giving away after the program. Ways to become eligible for this giveaway are to send in chats, send in your questions, and to fill out our post-webinar survey that is attached in the handouts, but we'll also post the link in the chat toward the end of our session. So getting into our topic, how to achieve agility with stability. And I'm joined today by Sergey Katsev, VP of Engineering at Catchpoint, and Leo Vasilou, former DevOps practitioner and author of the SRE report at Catchpoint. So Sergey and Leo, thank you all so much for joining us today on Tech Strong Learning. Leo, would you like to dive us right into things?
Yes, absolutely, Cody. So hello, everyone. As you mentioned, my name is Leo Vasilou. And first, I just want to take a moment to say thank you for giving us some of your precious time today. Welcome to How to Achieve Agility with Stability. I have the wonderful pleasure of being joined by one of the smartest people I know. Sergey, would you maybe take a second to introduce yourself?
Sure, but where's that person? Just kidding. So, hey, everybody, Sergey Katsev. I am VP of Engineering here at Catchpoint, and my job is to build the Catchpoint platform and make sure that it's stable.
Make sure that it's stable and also agile, right? But kidding aside, Sergey, why are we here? Why are we asking people to, in fact, give us some of their time today?
Yeah, so ideally, when this session is over, you know how to build better software, even if it's just a little bit better. But who does this apply to? Well, DevOps practitioners, and in particular, it's DevOps practitioners that may be slightly more mature companies. And what I mean by that is when you're a company of maybe, let's say, 5 people, early stage startup, everyone does everything. Everyone wears 5 different hats, and those companies have to be agile in order to succeed. They don't have a choice. And it might be a little controversial to say it, but as a result of that, they don't necessarily need to be stable because they actually are trying to acquire customers, and that requires some experimentation. But then those companies grow up, and those are the companies that we're talking about today and hopefully talking to today. And once they grow up, they already have customers, and they need to not fail those customers. So that means they can't go down, they can't have major features break, they can't have bad data. At the same time, though, they can't stop innovating either. So that's what we mean by agility with stability. It's you keep innovating, you keep acquiring new customers, but at the same time, you keep your existing customers happy.
And Sergey, if I could start with a real question, not just why are we here, it's why more than 20 years later does this quintessential representation of why we talk about DevOps in the first place, why does this image still resonate?
Well, I guess the short answer is competing priorities, right? And it's that these companies that I mentioned a second ago, once they have those stability requirements, all of the sudden you have a team that's responsible for making sure that the product, the platform is stable. So maybe it's the operations team or the SRE team or the platform engineering team. Different companies call them different things, but that team is responsible for maintaining the existing products and making sure it's stable, while developers go and build new features and extend it and expand it. And so that's where the competing priorities come in. Developers want to move fast and break things, and operators would rather change nothing ever, because then they won't break. And the problem actually is even worse, right? Because it's no longer just developers and operators. Nowadays, most internet services have many dependencies, but when I talk to people, or when we hear tech people talk, they say, oh, my service, yeah, it's in Google, or it's in Amazon, or it's in Azure, and the cloud will take care of it for me, right? And they're not thinking through all of the dependencies. And so the different groups that are involved in developing and maintaining the product, again, have these competing priorities. And they might be analyzing the internal dependencies, like your databases, your servers, your storage, et cetera, but they're probably not looking at the external dependencies, your DNS, your CDN. Are you sending invoices to your customers via email? What happens if your email service goes down? You're not invoicing your customers. You're not getting money through the door anymore, right? And almost nobody thinks about the customer side. What happens if all of your customers are in one location and there's a major ISP outage there, right? All of a sudden they can't get to your application. Again, you're not making money, but they're still blaming you for your application not being available, right? And so the big question to ask yourself is stability impacted when any of these services I mentioned, any of these dependencies are impacted?
Nice framing, Sergi. And before we continue, by the way, did you know that the girl in this Disaster Girl meme is now 24 years old, right? Born in 2000, and they sold this original meme, not the one here on the screen, as an NFT for $473,000. So you never know what will make us rich. And just kind of in continuing with the thought that there's nothing wrong. Excuse me, that there's nothing wrong with a little humor. So really, we're talking about here, this idea of agility and stability. But as you can see from the visual here, why do we have this as a tough choice? And sounds like you've got some experience from which to speak.
Yeah. So first of all, thank you for portraying me as a superhero. I appreciate that. But yeah, this meme, I know you're trying to be funny, actually kind of brings up flashbacks for me and probably some of our viewers here. Flashbacks to where I made the wrong decision. Right, I chose agility where I should have chosen stability, and it's a tough choice because as engineering leaders, we always want to move as fast as possible. Time is money. We want to minimize the toil for our teams. We want them to be as productive as possible. We want them to work on the most interesting projects as possible. But at the same time, moving too fast without having the right system set up to observe what's going on inside of our applications, our platforms, that can cause massive issues. And so what I always hear is, well, the way to reduce toil is just to automate, just do CI/CD, no problem. And the reality is, of course, it's a lot easier said than done. To do CI/CD properly, you need to understand your whole system. And humans are very bad at understanding complex systems without help. I'll talk a little bit more about that later. But the idea is, first, you need something to help us understand the complexity of the systems we're building, understand it and measure it. Then we know how to implement CI/CD, and we know how to fix problems that come up as the system, that CI/CD continuum is running. And only then can we actually start relying on it. Because if you can't trust the system, then you're not going to rely on it.
And, it's an interesting comment about toil, our desire to automate all things, if you will. And we don't want to necessarily paint a picture of doom and gloom here. As I mentioned in the beginning of the recording, we author the SRE report every year. And so through the years, we've been doing it for 7 years. And so thousands and thousands of practitioners respond. And we do ask a toil question each year. So the good news is I could say we're heading in the right direction because for the 7 years we've been doing the report, the numbers have in fact been trending down to the simple question, how much of your time is spent on toil? So not all doom and gloom there. And the other comment that you mentioned, you said something about needing to understand complexity and how difficult it can be. So for this session, we're talking about this concept of internet performance monitoring, or IPM. Is that correct?
Yeah, of course. And so just, I guess, disclaimer, yes, my role as VP of engineering is that I'm responsible for the development of Catchpoint's IPM platform. But at the same time, if you think back to that intro I gave in the first slide, Catchpoint very much falls into those categories that I described. We have a large customer base. They rely on us and we can't let them down. We have a large infrastructure that has thousands of components and many, many dependencies. But all of that being true, one of my jobs is still to keep innovating and keep delivering new functionality and new features. So here at Catchpoint, we have to be both agile and stable. And so IPM is one of the tools that we use to achieve that.
And I'm realizing that this concept of IPM might be a term people haven't heard before. So if I could just take a second to talk about what IPM is, and then we'll get back to discussing IPM's role in CI/CD, right? So the idea is that, right, you've got this this stack of components, right? So this concept of monitoring your internet stack, if you will. And when we think about the complexity and distribution of the internet as your new development platform, it's not a matter of if an incident will occur. It is a matter of when, and maybe even more importantly, what are you prepared to lose, or what are you prepared for the impact to be, or maybe potentially absorb. And I'm pleased to provide a sneak peek at some upcoming research which we'll be releasing soon, to show just how large total economic impact can be. In other words, before we get an understanding of IPM, why do we even need to care about this at all? And as you can see in this almost near distribution here, that 42% of the 330 IT and digital business leaders who responded to the survey said that total economic impact was between $500,000 and $5 million. So definitely a lot on the line here. And getting back to now, what exactly is IPM? Well, it's like application performance monitoring, or APM, but for your internet stack, where legacy APM solutions have no reach, right? You can't install APM agents on your DNS, your CDN, your third-party API providers, and there are tons of these third-party providers out there where those providers, even though you can't install APM agents on them, they're still critical for us to make money that pays our rents and our mortgages. And so just as APM is a powerful encapsulating term to represent a set of capabilities in a single word, so too is IPM. If necessity drives invention, then the need for talking about IPM arises from certain inflection points, if you will, things like an anytime, anywhere workforce or unrelenting customer expectations and their ability to control the narrative thanks to how easy it is for them to switch in a digital world. And so IPM provides your internet cloud native telemetry to expand the boundary of your observability frameworks where agent-based APM has no reach, and IPM being closer indicators to your users' experience and businesses' KPIs.
Thank you for that. And I think another change that is certainly driving the need for IPM is just the increasing complexity overall. And that's a trend that we certainly keep revisiting through this whole conversation. So IPM is basically a Swiss Army knife, right? There are a lot of things that it can help with, but this conversation is specific to CI/CD. And so I kind of look at 4 specific areas where IPM can help CI/CD. And so going through them from right to left, I use slightly different terms than what the slide has here, right? So the slide has, for example, shift wide, and we'll talk about that in a second. I call that fear of the unknown, because if you don't know what's going on in your system, or even worse, if you don't know what you don't know, then you can't make the right decisions. The next one, resilience where it's most important. So IPM is a model that helps you understand dependencies, prioritize them, and make sure that there are redundancies or failbacks where they're necessary, and that they aren't there when they're not necessary, so you're not spending money on things you don't need. Keeping along with the dependency theme, monitor your tooling. Well, IPM also helps you figure out dependencies that you wouldn't normally think of, but that will impact you if they failed. And then finally, we tie it all together with this nice automated bow, because it's CI/CD, right? So everything has to be automated in order into your CI/CD pipeline in order to actually help. And so what we'll do for the rest of the conversation is go through each one of these 4 areas in detail, and then at the end, wrap it up with a sample process that you can actually apply within your software development lifecycle. And the process, hopefully, if applied correctly, will make your SDLC more agile and more stable.
And let's just jump right in. So shift wide, left and right. I mean, Sergi, if you could just take a minute and explain what the heck do we actually mean when we say this, maybe settle the debate once and for all, if possible.
Sure. So quick sneak, there is no right answer. But let's back up for a second. So just to make sure that we're clear on definitions, shift left is the concept that by moving things to earlier in the development process, you find problems faster, and by finding problems faster, it costs less, right? The further along in the process, the longer it takes to find a problem, the more it costs. But the reality is that it's usually true, but it's not always true. So a couple of examples: think of a scenario where you have very, very complex data that needs to be reproduced in, let's say, a QA environment in order to test something. It might take hours, days, even longer to create that data synthetically in your QA environment, whereas it just exists in production, right? Another example is, let's say you change the color of a button. Well, if a trivial change didn't work properly, there's probably no significant impact. So is it worth it for the business to spend resources to test it in QA, or can it be shifted right and tested in production, right? So shifting right is the idea that sometimes, and I definitely emphasize sometimes, it is okay to test in production. But to do it properly, you need the right analysis that it's okay to test it in production. You need to be able to react quickly if and when there's a problem, like maybe you apply feature flags or something like that. And most importantly, you need to be able to fix any problems quickly. And of course, to fix problems quickly, you need IPM. And if you're not shifting right, if you're shifting left, one of the biggest benefits of IPM is that it creates a common language, a common set of baselines that all of the different teams that are responsible for different stages of your software development lifecycle can now use to actually communicate together. So to take this concept of shifting left or right, we can finally bring up the CI/CD pipeline, right? We've talked about it a couple of times, but in the last example, the two stages that we kind of talked about were the build stage and the test stage, or maybe test and release. But you can apply the same concepts for plan and code, or maybe even plan and operate, right? The two stages don't have to be next to each other to apply this. And that's why monitor there right in the middle is such an important stage of the CI/CD pipeline. It helps create a ground truth. And like I called it on the previous slide, a common language. With it, for example, your product management team can specify what the performance of the system needs to be. Then they can work with your DevOps or your operations team to create a monitoring strategy. And they can do all this before your software even exists, which is the great part, right? Then the developers can use that same data that's already being collected to make sure their code works properly. The testers can use it for their system testing, for their automation. And by the time it comes to operations, to actually deploy it and operate it, everyone is sure that they're on the same page and that the system is working properly, right? So I call this OSDLC, Observable Software Development Lifecycle. It hasn't caught on yet. Working on that.
We're here to help. We're here to help.
And so one of the problems we talk about DevOps and CI/CD, one of the problems that DevOps was created to address was this throw it over the wall problem, right? Again, we're talking about, well, there's different stakeholders at each stage of that CI/CD continuum, and they just kind of say, okay, your turn, your turn, your turn. And if OSDLC is implemented properly, it actually fixes the throw it over the wall problem, right? Because again, everyone is speaking the same language. They have the same ground truth. It's a lot easier to have those conversations. And in fact, there have been plenty of solutions proposed for throw it over the wall, right? DevOps itself, as I said, was originally a solution proposed for throw it over the wall. They said, hey, developers and operators aren't great at talking to each other, so let's mush them together, call it DevOps, and then they're forced to talk to each other. They're part of the same team. But again, there's competing objectives between agility and stability, and so it doesn't work unless you wrap other things like OSDLC around it, right? Shift left and shift right are great, but again, they're not solutions to the problem. They almost work in spite of the problem. You need to have that ground truth, and then you can shift left or shift right. TDD, or test-driven development, great, big fan of it. It works really, really well for functional requirements and feeding those from the beginning to the end of the software development lifecycle. OSDLC does the same thing, but for non-functional requirements, so that you can flow them from the beginning to the end and through the operating stage.
OSDLC, I heard it here first.
OSDLC, that's right. Just keep repeating that. It just rolls off the tongue. And so just one more comment on OSDLC, if I may. And so you have a picture of two cars here, right? They have the same engine. And the point here is the car on the right, well, that's an Audi with an Audi twin turbo V8 engine in it. The car on the left is a Volkswagen Bug with an Audi twin turbo V8 engine in it. You can retrofit engines. That Bug, I'm sure, runs a whole lot faster than it did before that engine was in it, but it's still a Bug, and the Audi is still an Audi, right? So think of this analogy the same way for observability or OSDLC. The earlier you integrate it into your process and start following it, the less you have to retrofit it at the end, and you will get better results.
All right. So here's what I heard. Right. So shift wide, standardized, consistent measurements, common truth, common language. So different people, different teams are not responding differently to what they believe to be real signals, even though those signals may be different. And if we just kind of build on top of that, what I would say is, in order to have those measurements in the first place, we need to connect in the first place. So now if we could just take a quick second here and talk about IPM's role in this idea of resilient connectivity. And if I were to ask, Sergi, a lot of people assume that this, beautiful looking, I don't know if it was AI generated or not, but
it's definitely AI generated.
A lot of people assume that this is the environment in which their software operates, or maybe they assume if they monitor right here at the source or take those measurements right here at the source, that that's good enough to understand what the user's experience, right? That anywhere, anytime user's experience will be like. But I guess just a sanity check, Sergi, that's simply not true, is it?
You wouldn't have asked if it was. So of course, no, it's not true. And the reality is most applications are distributed, but even if you have an application that runs on one of those little boxes on that, in that image, there's still external dependencies, right? You have your DNS or CDN, for example. If you're in the cloud, then probably your services are distributed across different availability regions, right? Or different zones. And remember that regardless of which setup you have, if you're on-premise in a data center or on-premise with, a server in your basement or in the cloud, unless you take all of your users and shove them into that little AI-generated data center, they all have their own dependencies. And unless all of those dependencies are working properly, they're going to impact your service. So you better know about them as well.
And what you're saying is that this is in fact the reality of where our apps are consumed, right? Different users, right? I know I've said it a couple of times, right? Anywhere, anytime users, accessing them through different methods. Maybe the Wi-Fi at Enzo's is perfect, but in the apartment in the top left, the person is in bed using a ton of bandwidth. And so the application doesn't work properly for the person in the window. And then there's the person on the left trying to use your app from their phone while in the restroom. And hopefully you kind of get the idea at this point. And justified or not, if their experience is slow, it's your fault, not theirs, right? So what was that meme in the beginning? Worked fine in the cloud, customers problem now. And just to put a finer point on it, every one of those dots on the right is their own versions of Enzo's restaurant. They've each got their own unique performance fingerprint, if you will. And each one of those dots is connected by this thing called the internet, right? All going across the internet stack. So, Serge, maybe just getting back to what you were talking about, size, complexity, distribution, and dependencies. What do you think about that?
Yeah. So, well, there's more and more dependencies and more complexity. That's what I think about it, right? And so, yes, the internet and applications nowadays are on this internet stack, and it's a distributed internet stack with the dependency separated by hundreds of miles, sometimes continents, right? And we can no longer rely on everything just working. So we have to understand the dependencies in order to understand the whole system so that we can make sure that everything is working. But as I mentioned before, humans are bad at understanding dependencies. So if you'll just forgive the tangent for a second, I want to share a story real quick. So I went to this lecture at MIT a few months ago. I was lucky enough to attend. And this professor of systems engineering, Dr. Siddiqui, talked about how dependencies didn't used to be a thing. And I'm way oversimplifying what she said, but the idea is all of our major systems were actually independent until, get this, about 2000, 20-something years ago. So transportation systems, communication systems, the electrical grid, pretty much completely independent of each other. Then you fast forward to now, and all of them have major dependencies on each other. And this is just, of course, an example of 3 now expanded for all the systems, right? So, for example, transportation and communication, well, they use GPS, right? And that's a dependency between the 2 of them. Transportation and the electrical grid, electric cars, right? Yeah. And it goes on and on and on. Plus, on top of that, everything is digitally connected. Another example to sort of go back in time a bit, if you think back to when people were hunter-gatherers, right? A long, long, long time ago. I don't think you remember that far back. They would go hunting, and what one person did had very limited impact. Then you fast forward to the printing press, and now all of a sudden, if the printing press fails, maybe you can't print 100 books or 1,000 books, right? So certainly bigger impact, but still pretty contained. Then you fast forward to the internet, and the complexity and the dependencies, they're just increasing exponentially, literally every year. And so we as humans need a bunch more cognitive energy to remember and understand all of those dependencies. And we've never had to do that ever before, all through humanity, right? And so because that impact keeps growing, you showed the bar graph earlier, now the impact isn't maybe a family or a couple of thousand books. Now it's millions or even billions of dollars of damage. Yeah. Right. And so a few years ago, I asked a financial customer what their success criteria is, right? A pretty standard question. And the answer was, I don't want to end up on the front page of CNN. So I think that kind of summarizes it, right? That is the cost of failed dependency analysis nowadays, and not understanding how your full system works. And so one of the things that I do both with my internal teams in engineering, but also with customers, is perform a dependency analysis exercise. And it looks something like this. Just for the sake of time, I'll plug in some examples here. And the idea is that you analyze all of the components that make up the system, right? You have your internal applications, your customer applications, and all of their dependencies. And then you rank them based on how much control you have over them, which is very important. So in most cases, we'll start with the customer applications. If you're a SaaS vendor like Catchpoint, your product probably falls into this category, and you have a lot of control over it. You probably run the servers, you deploy the software, you probably control the network, no issues. But then you might have an application like Zendesk. So we at Catchpoint use Zendesk for our support portal. It's still customer facing. Customers need it to be up. They rely on it, but we don't have control over it, right? It runs inside of Zendesk's data center. Once you identify those, you go through all of the dependencies, the BGPs, the DNS providers, the email, the CDN, et cetera, right? That's all on the right side there. And then finally, make sure that you go through the internal applications that your teams use, and we'll talk about that in the next section. Once you've written it all out, which ones are the most important, right? Because if they experience an issue, what's going to happen to your application, right? If Zendesk goes down, what happens to Catchpoint? If email goes down, what happens? What's the impact to Catchpoint, et cetera, right? But for your application. And just as importantly, if something happens to them, how do you measure that something's happening to them? How do you have that visibility?
Yeah, Sergey, and that was a nice way to frame it. And some of the points that you made kind of hit home a little bit. Never really thought about it in that way, especially when I was talking about the total economic impact and how you kind of told the story leading up to it. And I think here this visual, if a picture's worth 1,000 words, kind of thing. I think this visual maybe reinforces that dependency concept, right? So. Just to give another example, we here at Catchpoint, we use a platform, Pendo, to capture some of our user in-portal feedback. But, and we happen to be looking at a screenshot from our own product here, what we call Stack Map, right? Just a way to visualize these dependencies. But if Pendo, who uses GCP, right, Google Cloud. So if Google Cloud goes into incident, from our perspective, right, our initial thought is like, hey, what the heck is going on with Pendo? Just to come to find out that they had this dependency. And again, from that whole perspective is like, it still is Pendo's fault, if you will. So understanding the dependencies is a critical use case for IPM needed to achieve that agility and stability. But as you kind of said, that understanding won't be obvious unless there's a way to visualize it or at least hasten the troubleshooting.
Exactly. And one of the things, by the way, that we are working on in Catchpoint Engineering is this stack map and helping you perform that dependency analysis so that we can do it, as much of it as possible for you. So to tie it back to the CI/CD conversation, go back to this continuum, right? In the first section, we talked about how IPM is this common language and it helps you understand that the whole system is working properly. And that covers the parts of the system that you control, your internal components. Well, but with this dependency analysis, now we extend that. And now we can also cover all of the things that your internal components depend on, even if they're outside of your control, and they will still have an impact on your system, right? So here's a quick concrete example. This one's made up. So let's say at 2 in the morning, because they always happen at 2 in the morning, there's a crisis call because the number of users from Asia to your application dropped to 0. So the operations team, number one, they know that there's a problem in the first place, right? And knowing is half the battle. So the right systems are in place to tell them that. That's great. Number two, they don't need to bring in developers to help figure out what's going on, right? They can solve the problem themselves. They can see that, in this case, it's localized to Asia. They can see that it's because there's a major ISP outage in Asia. Maybe they're using something like Catchpoint's Internet Sonar to figure that out. And then they can decide, do they want to reroute traffic around that ISP? Or maybe they just want to post an announcement and go back to sleep. But the decision is theirs, and that's the point.
All right. So, talking about standardized measurements, resilience for the things that matter, right? We've talked about how IPM helps you understand how your software works and is working, how that helps your teams fix problems faster, hopefully be happier, prevent that impact that we've been talking about, understand dependencies. And I know it says monitor your tooling here, but how else, Sergey, does IPM help your team?
Yeah, so certainly the example I gave a second ago of not being called at 2 in the morning is a solid example. I'm a big fan of that one. But let's go back to this picture again for a second, right? Same exact picture, same exact people, but now they're portraying different roles, right? So now they're not the users that are connecting to your application from Enzo's and from the bedroom and from the restroom. These are actually developers. They work for your company. They are developing your software. But now, instead of having a poor experience and maybe not buying your product, they're having a poor experience working, right? Or a poor developer experience. And so they're not being productive because of how slow the systems are. They're going to miss the deadline for the next big feature. and a couple of them might actually quit because of that poor developer experience, right? So having visibility into that and being able to be proactive about it is another huge plus with IPM. And so going back to this for a second, each one of these icons here represents different services that you might rely on in your tool chain. Of course, these are just examples. There's thousands of different services that you might use, but each one has their own dependencies. And each one requires connectivity between them and their users and them and the other icons within the tool chain in order for that continuous integration and continuous deployment to happen. And if something goes wrong with that connectivity, you have no integration and you have no deployment. And it takes a long time to fix that unless you have visibility of where the problem is immediately. Right. So just to tell another quick story, we have a customer who's a large manufacturer, and they realized that their GitHub instance was having issues. So developers couldn't check in code. At the time, they weren't running it with, they weren't monitoring it with Catchpoint, and so they didn't realize that this problem was going on until developers started complaining about it during their daily stand-ups. Well, the stand-ups happened several hours after the problem started. And so that means that, number one, no developer raised the issue directly. Go figure. Number two, some developers worked on copies of older code that they had on their laptops already. Other developers just stopped working, waited for the problem to go away and twiddled their thumbs, right? And so this relatively short interruption had a bunch of cascading effects that lasted for days. And because, again, the interruption itself lasted hours, but because of those cascading effects, they actually missed their manufacturing targets. And so since then, they've set up Catchpoint for their entire CI/CD tool chain, their whole pipeline. And so now they know whenever there's any kind of slowdown, they can be proactive about it with that monitoring and address it immediately before it starts impacting their team. And so that's why in that analysis example a few slides ago, we include the internal development applications, right? By making sure that you cover tooling in that IPM dependency analysis, you help ensure the resilience of both your internal pipeline as well as your customer applications.
And Sergi, if I may, you made a comment earlier, something to the effect of the things you might not think about, right? And I think that was a nice little story to reinforce that. And so in addition to the things that we might not think about, again, the standardized measurements, so we're not measuring in feet and inches in your CI, but the metric system for your CD, resilient connectivity, right? That anytime, anywhere workforce or customers and monitoring your tool chain, ensuring developer experience. But I think we alluded to this earlier. In order to amplify the benefits, we need automation, right? And I mean, I asked that question, and I just go back to our previous comments about toil. So, Sergi, maybe just elaborate on how IPM has a role to play here as well.
Yeah, 100%. And not only do we need automation, that automation has to be seamless and simple, right? So, and in order for it to be seamless and simple, the observability that you are implementing as part of your OS DLC has to be treated as code, right? So you have your design reviews, you have your code reviews, you have repeatable templates that can be applied when a new feature is developed. If it's not easy to do, people won't do it. And so with Catchpoint, of course, we have a number of different ways to incorporate IPM into your CI/CD pipeline. One example of kind of the most mature way I've seen to do it is to create new test configurations as new features are released. You do that using your REST API, new features for your application, that is. You tag deployments, you run ad hoc testing to make sure things are working. You notify stakeholders, or you trigger actions or other automations using webhooks or emails. And then you send all of that collected metrics data to a different data warehouse in order to combine it with other data sources for other outcomes, your business KPI reporting, for example. So that to me is kind of the full end-to-end of CI/CD automation with IPM.
Makes absolute sense, Sergi. And, just kind of going back to what we're talking about here, and it's like there's a little bit of like maybe pause is like, oh, not another set of data. And I remember a couple of SRE surveys ago, it's been a couple of years, when we asked this question, and we ask simple questions, right? We're not trying to trick anybody. It was, do you prefer best of breed, or do you prefer just a checkbox? It should not surprise you that the majority of respondents, again, individual practitioners, the majority said they prefer best of breed, which is great to hear. And I think it's great because it means you don't have to replace existing tools. Instead, you can use IPM, Internet Performance Monitoring, for your best of breed internet telemetry from your internet stack, regardless of existing tools that you know and love. And so, we do purport to build best of breed and can solve all of the IPM use cases and others. And if by chance there's some use case that we can't solve directly, our general ethos is to be a good netizen and to make sure that you can still use those other preferred tools and then combine our data with theirs. And it doesn't matter if you build your own or if you use any of our out of the box integration. So good to know.
Yep, absolutely. Yeah, so maybe let's kind of start wrapping it up a little bit and recap these 4 categories, and then we'll give that example of the full flow. So this time we'll go in the opposite order, if I may. So we talked about how to add observability as code into a robust observable SDLC, OSDLC. We also talked about how to properly analyze dependencies and make sure that both your internal users, your employees, and your external users, your customers, are considered, evaluated, and monitored so that you know what potential impacts are. And finally, we started by talking about the role of IPM in the CI/CD pipeline overall, how it provides a common language for different teams, that these teams are responsible for different stages of the pipeline, but with this common language, they're able to talk to each other. And IPM also provides the data to make data-driven decisions, for example, shift left or shift right. And it provides that ground truth that can be followed from the beginning to the end of the software development lifecycle. And then when that continuum starts going around again, it can be used as that feedback loop when the cycle starts again. So with that, let's go through a quick example of doing this, right? So this is almost a template that you can apply, or a checklist that you can apply to make sure that you're doing IPM in your CI/CD the right way, right? And so we'll start with kind of top middle there with define IPM requirements. So what should the performance of the system be? What are the resilience requirements for the system overall? Then we can figure out what's the right IPM strategy for the system. And that depends a lot on the complexity, the use cases, frankly, the customers, the SLAs. There's a lot that goes into that. And from that strategy, you'll find out what you actually need to implement for monitoring. Do you need synthetic or real user monitoring? What parts of the stack do you need to actually observe? Is it the network? Is it the application? Is it something else? Do you need client-side tracing, server-side tracing? All of the different dependencies, right, that we talked about. And so that's where you start analyzing your internet stack. So you start out with your internal application, then you extend that analysis to the internet stack, and you add all of those external dependencies to the IPM strategy. Now you actually go and you implement the IPM strategy. Ideally, you do it as code, as we talked about, with repeatable, easy to use templates. You do this for both the external application and the tool chain itself. So at this stage, you have your IPM strategy implemented and you're collecting data, right? So as you continue to go around and around and around, you're certainly iterating on that, but now you're making data-driven decisions.
Yeah.
And so you can verify the requirements of each stage of the process as you go along the way. You can integrate that data with other systems to help make decisions, like we talked about, driving business KPIs, right? And so as a result, of course, the point of this conversation, your software is more stable. You can incorporate the data into that next feedback loop when you start the cycle all over again. And each loop is shorter than it would otherwise be. Because, why? Because you already have the data. And so you can know what the problems are and make data-driven decisions to solve them. And that's what agility with stability is.
Agility with stability, and oh, by the way, observable SDLC, OSDLC. One last time.
One more plug.
So, Sergi, I guess if I'll go ahead and kind of click to this next slide here, I suppose we do need an obligatory advertisement here for Catchpoint since we're at the end of the presentation. Before I talk quickly through these last couple slides here, I just want to take a second to say thank you for your time. I understand that you've got to go. You won't be here for the Q&A, but definitely will offer for anyone to follow up with us afterward. If we want to follow up with you offline, again, one of the smartest people I know, and I just want to say I'm always grateful when engineering takes the time to do these sessions with me. So again, thank you very much, Sergi.
Absolutely, likewise.
So IPM's role in agility with stability, right? We talk about solutions for your customers, solutions for your workforce, your applications, your network, and your website. How do we do that? Well, we do that with an array of products. So synthetic monitoring, internet synthetic monitoring, real user, BGP, endpoint, web page test, internet sonar, and tracing. And so that's the how we do it. And well, how do we do it better than anyone else? Well, we do this by offering the world's largest commercially available active monitoring network, so you can match the performance fingerprint of your customers, of your workforce, of your partners, if you will. And with the flexibility to change as your use cases change. And I'll just add a little cherry on top and say that, by the way, 100% of the feature functions that we talked about from this public set of active monitoring vantage points can extend behind your firewall on your premise anywhere there's an internet connection with what we call our enterprise nodes. And with that, kindly, gently invite you to experience Catchpoint for yourself. Please visit catchpoint.com/tour. And Cody, I guess if we could go ahead and stop the screen share, we can see if there's any other questions in the Q&A. So I'll see you back on stage.
All right, Leo. So it looks like we have received quite a few questions here. So let's go ahead and just start taking them from the top. But I'd also like to let everyone know at the top of the chat and handouts, you'll see not only this tour link that you're seeing on screen is the currently pinned handout, but there's also a link to our post-webinar survey there in the chat. So looking at our questions, Leo, we've gotten quite a few. Our first one reads, can you provide examples of how organizations can achieve agility while maintaining stability in their software delivery and operational processes?
Yes, Cody, absolutely. So first, just a quick thanks to Sergi, who couldn't finish out the last couple of minutes with us. And then also was overwhelmed by the questions. I tried to answer them as many as I could while I wasn't engaged as best I can. And, so there were a couple of questions that I thought were related. So if I could direct people's attention to the latest link in the chat, you can kind of pull that up as a visual too. Excuse me. To kind of, give a little bit of context as I speak to, because, we try to kind of sprinkle, to get to the question, sprinkle those use cases in through the presentation. Sometimes, when you're painting a picture or setting the stage for the story, you might miss some of the key points. So if you think about Catchpoint as an internet performance monitoring platform, right? Internet providing telemetry for your internet stack, where at the heart of our product functionality is directly monitoring an array of protocols or providing internet stack telemetry for your observability framework. We'll go back to, the 4 circles where we talked about best of breed IPM data, regardless of what APM you might be using on the back end. So just to kind of summarize the critical points there, what we're talking about is standardized measurements across your CI/CD lifecycle. So you're not measuring with feet and inches in your CI, versus maybe the metric system in your CD. The second one, for your anytime, anywhere workforce or customers, will be the idea of resilient connectivity, resilient where it matters most, because people are working and experiencing consuming your products and services that pay our rent and mortgages from, that quote unquote Enzo's Trattoria, where each one of those dots on that globe that we put has their own version of Enzo's Trattoria. Then the next one is the idea of monitoring your tool chain and your platforms, where more and more of those critical dependencies are cloud-based, right? And then to go back to what Sergi was saying, is none of this will matter if it's not easy. So whether you want to call it monitoring as code, observability as code, IPM as code, the ability to automate and treat your monitors, your monitor instruments as code. Right. So those are the 4 critical ways that will help find balance. And Sergi sprinkled in, a little elaboration on those use cases throughout the webinar.
Great. Thank you so much, Leo. Another question that we received is from Kaushik. What is the security model of IPM? Is there any authentication or authorization process involved? And then as a follow-up, how can we integrate with third-party SaaS?
Right. So for it will be relative a little bit to what the use case is, right? So for your basic use cases, and if you kind of go back to that active monitoring network, let's say you've got a basic use case of uptime and you just want to do an HTTP GET to check for a 200 code, maybe parse the response to get a custom code, which is one of the unique things we can do. We can extract those custom codes, turn them into additional telemetry. But in a case like that, it will just be relative to that protocol, right? Web. But then there may be advanced use cases which require your authorizations, your authentications. In these cases, what we would do, we'd augment our monitoring observability capabilities with a vault credential. And this is just an example because we don't have much time yet, but use something like a vault or shard to execute a complex API transaction. And then I also wasn't sure about like the platform itself. So we have our various compliance, right? SOC, ISO compliant, and then adhere to some of the strictest security requirements that are custom for some of our customers. And then,
right, well,
sorry, the second part there, right? So as far as SaaS goes, so SaaS monitoring, we think about our workforce. That is one of our primary use cases, and it will be relevant related to what their instrumentation is. So, for example, if we're talking about tracing, we're proud to offer OTel support as at the forefront of our tracing, but we also may do things like use custom indicators or suites to capture some of those SaaS APIs. And then it will also depend on the product. If you recall that product screen, depending on if it's real user or client endpoints capturing telemetry from your users or workforce accessing them. But yeah, those are just some of the quick ways in which we integrate with the third parties SaaS and what they offer.
Perfect. Well, Leo, thank you so much. We are unfortunately at the end of our time. I know we could spend another 30 minutes or hour here talking, but I do appreciate the hour that you have already spent here with us today. So thank you so much for joining us on TechStrong Learning.
Likewise, thank you, Cody, and thank you, team, everyone, for giving us your time today.
Absolutely. So before I dismiss our audience, stick around for just one more moment, a couple of closing announcements. You will receive a recording of today's session via email here shortly, and you can also find it living on the DevOps website. Just visit devops.com/webinars. I will be selecting 2 lucky attendees today to win a $50 Amazon gift card. So thank you for your chats and your questions, which made you eligible. You can still become eligible by filling out our survey that is in the handouts as well as pinned at the top of the chat. I'd like to thank Catchpoint for sponsoring our program today. And to everyone here, thank you so much for joining us. We appreciate you spending time with us here, and we hope to see you at a future TechStrong Learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, Leo. And to Sergi, of course.